Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. As once more, today we are commencing a new topic. One of the topics that most students find very difficult or very challenging, but it's quite a straightforward topic if you just manage to master the basic concepts to proof of identities. So basically, we have got standard identities that we have. They are already given for us. What we are just supposed to do is to be able to remember them and to use them wherever we are required to. So the basic standard identities that we have that are given to us are the first one here that is given: cos squared theta plus sine squared theta equal to 1. So this is a basic standard identity that you've got to keep in mind. So for us to be able to derive other identities, we can just divide, right? If we divide the whole equation by cos squared theta, like what we've done here, cos squared theta, cos squared theta, cos squared theta. So we're ultimately going to get 1, because this one and this one are going to cancel out. 1 plus sine squared theta over cos squared theta is equal to tan squared theta, right? Then 1 over cos squared theta is equal to sec squared theta. So this is our second standard identity that I've got to keep in mind. The third identity that we have, since on the second standard identity we divided the whole equation by cos squared theta, this time around we can divide the whole equation by sine squared theta, right? So if we divide the whole equation by sine squared theta, we are ultimately going to get cot squared theta plus 1 equal to cos sec squared theta. And this is our third identity that we have as a standard one. So remember that cos theta equal to cos of theta, right? Then 1 over cos theta, or the inverse of 1 of cos theta, which is cos the power of negative 1 theta, which is here, is equal to sec theta. That is why previously you saw us saying 1 over cos squared theta is equal to sec squared theta. We are getting it from here. There's a standard identity that says 1 over cos theta, or cos the power of negative 1 theta, which is similar, is equal to sec theta. Clear, right? Then sine theta equal to sine theta, as you can see here. But the inverse of sine theta, which is 1 over sine theta, or sine the power of negative 1 theta, is equal to cos sec theta. That is why you saw us saying that 1 over sine squared theta is equal to cos sec squared theta, because the original identity is that 1 over sine theta is equals to cos sec theta. So if we just square sine here, like what we've done here, we're just going to square the cos as well. So it's similar. So the next identity is that sine theta over cos theta is equal to tan of theta. So you've got to make sure that you understand and memorize these ones. There are no two ways about it. You just are supposed to memorize them. So now, cos of theta over sine theta is similar to 1 over tan theta, or the inverse of theta, which is equal to ultimately cot theta, right? That is why you saw us previously saying cos squared theta over sine squared theta is equal to cot squared theta, right? So this is a standard identity that we've got to keep it at the back of our mind. So apart from these ones, we also have what called the double angle formula, right? Which is also a standard identity form that we are supposed to be able to remember and recall so that we can use them. So under the double angle formula, cos A plus B. To expand this, you say cos here A, cos of B. So you multiply cos A, cos, well, you also multiply it by B. Then you say minus. So here we've got a plus. But on cos A plus B, you say minus. Take note. Then you change, you now say sine A, sine of B. I think this is quite straightforward. It's just cos A plus B equal to cos A cos B. Instead of putting a plus, what we have on the right hand side, you're going to put a negative sign when you are dealing with cos, right? You change the sign when you are dealing with cos. So it's cos A plus B equal to cos A cos B minus sine A sine B. It's a standard identity. Then if we now have cos A minus B, is the same principle that we did before. It's cos A cos B. Instead of putting negative sign that we have here, you're going to put a positive sign. So it's cos A cos B plus sine A sine B. It's quite straightforward, right? Then another standard identity that we have again, now we're dealing with sine. Sine A plus B is equal to sine of A cos of B plus sine of B cos of A. So I want you to note the difference here. When we were dealing with cos, we are just going to group the cos together and the sine together, like cos A cos B, sine A sine B. But when dealing with sine, the first difference is that you're going to alternate. So it's sine of A cos of B plus sine of B cos of A. And when dealing with sine again, we don't change the sign here. Remember, on the left and right hand side we've got a plus sign. On the left hand side we've got a plus sign. But then when we were dealing with cos, on the right hand side we've got plus sign, and on the left hand side we said we put a negative sign. When we've got a negative sign here, we put a positive sign here. So now sine of A minus B equal to sine of A cos of B minus sine of B cos of A. We've got a negative sign here. Also, we've got a negative sign here. So make sure that you understand these. There are no two ways about it, guys. It's unfortunate, right? Just make sure that we memorize them and we get to understand them. These are the standard identities that we will use. We will really, really, really need them in future for us to be able to solve identities. Thank you.